Hey, hello everyone. I'm Dr. Santosh Chajed. I'm from PhD Pharmaceutical Sciences. Moving forward, so we will compare preliminary what difference is there between SN1 and SN2. Already made mention in case of SN1, tertiary alkyl halide will react to form a corresponding alcohol. This will occur in two steps. Whereas in case of SN2, primary alkyl halide will react to form a corresponding alcohol and this will occur in one step. So this is how, depending upon the structure of alkyl halide, whether it is primary or tertiary, path of reaction will be either SN1 and SN2. So now we will discuss nucleophilic substitution bimolecular, that is SN2 reaction first in detail. So as far as the SN2 is concerned, example of this is alkaline hydrolysis of methyl bromide, that is a reaction between methyl bromide and sodium hydroxide. We already discussed that a primary alkyl halide will undergo substitution reaction by SN2 manner, and so this reaction between methyl bromide and hydroxide ion produce methanol as a product. So now when we talk about the rate of reaction or kinetics of SN2 reaction, we will discuss reaction again. Reaction is there in front of you. This is a single step reaction where conversion of methyl bromide to methyl alcohol, that is methanol, takes place in one step. Rate of reaction will depend upon only one step, single step. That's why rate of reaction therefore depends upon concentration of both reactants, that is alkyl halide and hydroxide ion. So this is how rate is depend upon concentration of methyl bromide as well as hydroxide ion. And it is clear from the kinetics that the reaction requires a collision between hydroxide ion and methyl bromide molecules. As far as the mechanism is concerned, we already discussed that this is a single step mechanism where formation of COH bond and breakdown of CBr bond takes place simultaneously, synchronously. Before CBr bonds broken down, COH bonds start forming, and that's why it is difficult for nucleophile to attack from the same site as that of a bromide ion present, and it is said that is a nucleophile attacks or coordinates its electron with an electron deficient carbon from the side opposite or rear to that of bromide ion. So this is how reaction is there, in which methyl bromide reacts with OH minus to form methanol. We already discussed this, and this is how one step mechanism it is there in front of you, where nucleophile OH minus approach the carbon from the side opposite. Transition state is a pentavalent carbon where CBr bond is not completely broken down and COH bond is not completely formed, and that's why both are shown, that is OH and Br, with the help of partial charges, that is delta minus. Collision between hydroxide ion and methyl bromide molecule occur. Nucleophile OH attack from the side far away from the bromide ion, already made mention. So now we will see some of the fact in context to mechanism. So hydroxide ion collide with the methyl bromide molecule from the opposite side to that of the bromide, or we could say that it is away from or rear side as that of a bromide ion. When such collision has a sufficient energy, that COH bond starts form and CBr bond starts breaking, that liberate the bromide ion. The transition state is pictured as a structure in which carbon is partially bound to both OH minus as well as Br minus, and that's why this is said that these two phenomena, that is formation of COH bond and breakdown of CBr bond, occurs synchronously or simultaneously, as you can see in the picture. In continuation to the mechanism, there are certain aspects are there. We must discuss those, that when nucleophile is generated from NaOH, it has got a full negative charge because of excess of electron, and this negative charge start diminishing when OH minus coordinate its electron to the electron deficient carbon, and it is said that this negative charge on OH diminish slowly, and when bromide ion start departing from the carbon, it start developing the negative charge, and it is said that bromide has started developing a partial negative charge slowly. Now the OH minus and Br are located as far apart as possible. It is clear in the transition state, and the three hydrogens on the carbon lie in the single plane, all forms a bond angle of 120 degrees. The CH bonds are thus arranged like spokes of a wheel, with COH bond and CBr bond lying along the axle. So this is how this transition state is viewed as wheel of an cycle, and CH bonds are considered at its spokes. Now we will discuss about the stereochemistry, that is the three-dimension view of this particular reaction. So stereochemistry basically is a branch of a chemistry which deals with the three-dimensional structure of molecules. So we will talk about the stereochemistry of SN2. Before that, let me tell you that there is something called as the configuration. So configuration is nothing but the arrangement of substituent in the space, that is the three-dimensional arrangement of a substituent, we could say. Now when alkyl halide, that is methyl bromide, gets converted to methanol in the SN2 reaction, it has been observed that is configuration of 3 hydrogen become inverted, and that's why it is said that SN2 involves inversion of a configuration of a substituent around carbon, and it is said that this reaction proceeds with complete stereochemical inversion, that is 100% inversion of a configuration occurs in SN2 reaction. So this is how stereochemistry of SN2 reaction is. It involves 100% inversion of a configuration. Now there is something depending upon number of alkyl groups present. We already discussed that primary alkyl halide will undergo SN2 reaction, but we will compare the structure of alkyl halide with the rate of SN2 reaction. The moment you go on increasing the number of alkyl groups around the carbon to which bromide ion has become linked, what will happen? The transition state will become cloudy. So you could see that there are 4 different transition states are there depending upon nature of alkyl halide one has taken for carrying out nucleophilic substitution reaction, starting from methyl, ethyl, isopropyl and tertiary butyl. So what happens is, in case of methyl, Z and X, so X is a halogen, Z is any nucleophile. In general, we are discussing this reaction. So when there are 3 hydrogen present, crowding is less, and the moment you go on increasing the number of alkyl group, crowding around the carbon is increasing, and this crowding raises the energy of a transition state, and that's why it results in the slows down of rate of reaction. Number of alkyl group, if they are less on the carbon, rate of reaction will be high, and this is how in general we can conclude that difference in the rate of SN2 reaction, it is due to steric factors and not due to electronic factor. More the bulky group, slow will be the rate of reaction. Lastly, we will see difference between both the reaction. We already compare SN1 and SN2, but at a glance we will compare these 2 reactions so that it will be easier for students to memorize what is meant by SN1 and SN2. So example, what we discussed for SN1 was alkaline hydrolysis of tertiary butyl bromide. Example of SN2 was alkaline hydrolysis of methyl bromide. That is, primary alkyl halide will undergo nucleophilic substitution by bimolecular, and tertiary alkyl halide will undergo nucleophilic substitution reaction by unimolecular. SN1 follows the first order kinetics, whereas SN2 follow the second order kinetic. SN1 is a 2-step reaction. The first step involves the formation of a carbocation, and second step reaction, attack of a nucleophile on the carbocation. When we see SN2 reaction, it is a single step mechanism in which alkyl halide will get converted to corresponding alcohol in one step. Reactivity order of alkyl halide, so tertiary alkyl halide will give SN1 faster than secondary and primary. There in case of SN2, tertiary alkyl halide will produce alcohol by SN2 mechanism in slowest manner. As far as the stereochemistry is concerned, SN1 involves racemization, whereas SN2 involves 100% inversion of a configuration. So this is all about the mechanism, stereochemistry and rate of reaction or kinetics of an SN2 reaction. Thank you for watching. If you want to learn organic chemistry in very simplified manner, do subscribe my channel, share with your friends. Thank you.